Hello and welcome to the limestone section of the WJEC GCSE chemistry course. First, we are going to talk about metal carbonates. First, what is a carbonate? Well, a carbonate is this structure in which a carbon atom is bonded to three other oxygens, one of which is double bonded and the other two have a negative charge. Its formula is CO32-, and with that -2 charge, we can form different metal carbonates from positive metal ions. Here we have a table of +1, +2 and +3 ions and their respective carbonate. The first here is H2CO3, or carbonic acid, and is the only acidic carbonate. The colour here is representative of what the ion would do in a flame test. For example, here hydrogen would explode. Then we have lithium carbonate, which is red, sodium, which is orange, and potassium, which is lilac. Here are those +1 ions in the periodic table, and they require a 2:1 ratio for the ions. It must be noted here, though, that hydrogen is not a metal, and is therefore not a metal carbonate. For +2, we would have helium, but it forms no ions because it's a noble gas, beryllium carbonate, which is white, magnesium, which forms a bright white light, and calcium, which forms a brick red flame. We'll focus on calcium carbonate later, as this is literally limestone. Here, the ratio of ions is 1:1. For +3, we don't have boron, as it is a metalloid, and doesn't form metal carbonates, but has a bright green flame. Aluminum is white, and gallium is a deep blue. And here is aluminum. So what can we say about these metal carbonates? Well, let's have a look at the reactivity series for the first two metal ions. Here, aluminum is the least reactive, and potassium is the most. The more reactive these metals are, the more stable the carbonate is, and therefore is more likely to have a more violent or more exothermic reaction. For example, here, alkali metals in water. In this reaction, sodium is not very violent. It only produces a small amount of fizzing and maybe a few pops. Rubidium or cesium, however, is much more violent, as seen in this experiment run by Periodic Videos at the University of Nottingham. This also works in a displacement reaction, where a more reactive metal will replace the lesser metal. For example, here, where aluminum trichloride and potassium metal react to form potassium chloride and aluminum metal. Now we need to focus on the reactions of carbonates. First is that of neutralization. Carbonates are weak bases, and usually have a pH of around 8 or 9, whereas an acid like hydrochloric acid has a pH of 1 to 3. However, the products that are made, of which are a metal salt, water and carbon dioxide, have a pH that is quite neutral, around 7 or 8. Another reaction is that of thermal decomposition, where the metal carbonate is heated, and it drives off carbon dioxide to form the metal oxide. This is an important process that we will focus on over the course, especially in the production of concrete. One experiment we can perform is the thermal decomposition in a beaker. Then we can see whether the carbonate produces CO2 in the lime water test, or how stable the carbonate is by measuring how much CO2 it produces in a gas syringe.